All right, welcome everybody. Let's do this. So here, let's read this. What I want you to do is take a second, copy it down. Let's read the problem. It says, given sine of A is equal to -8 over square root of 73, and that angle A is in quadrant 4. Find the exact value of secant A in simplest radical form using a rational denominator. Okie dokie. So, how do we start off this problem, right? Like, what are we given? Let's look at the first information. You're given that sine of A is -8 over square root of 73, right? So remember that if this is our, initial ray over here, just like this in the green, we know that it finishes in quadrant 4. So our rotation will look something like this. And it's going to finish in quadrant 4, so this is the terminal ray. And notice what kind of triangle are we making? We make that right triangle, and this is it. So we have, this is angle A is over here, right? And we know that for sine of A, what do we know about sine? Sine is -8 over square root of 73, but we also know that it's opposite over hypotenuse, okay? So given this triangle over here, if we have that this is angle A, what is opposite of the angle A? It's this side here to here, and what's the distance from here to here? It's 8. We're not going to say it's -8, right? What is the hypotenuse of this triangle? It's opposite of the right angle, so we know that this is square root of 73. Okay. Now, why is sine of A, why is it a negative value? We have to remember that if we are in quadrant 4, sine is negative in quadrant 4. So that's why this sine value is negative. So what is the question asking from us? It's saying, hey, if you know that this is true so far, so we know this is 8, we know this is square root of 73, what's the question asking? It's asking you for secant of A. Okay, so what is secant of A? Now here we just have to go back to our notes a little bit, and that, if we have sine of theta, cosine theta, tangent theta, cosecant theta, secant theta. What is secant? Secant is hypotenuse over adjacent. Okay, so notice that we have the hypotenuse. We know that for the denominator it's square root of 73. For the numerator, we know it's square root of 73, but we don't know the adjacent side. We don't know this distance. So then what are we going to do? This is just the setup of, this is our C, our A, our B here. We could just use the Pythagorean theorem. So A squared plus B squared equals C squared, right? And how do we actually finish this up? We know that, what I want you to do is pause the video, try and find this side over here. We know that, let's say this is our A, right? We don't know A, so A squared we keep, plus 8 squared equals square root of 73, the whole thing squared, right? So then once we get to this point over here, let me zoom in the camera angle. How do we actually finish this up? This is A squared plus 64 equals, now when you square the square root, this cancels, so it's just left with 73. Then how do we get A squared by itself? Subtract 64, subtract 64, and then A squared equals 9. A is equal to, this is an A, this is a 9, so A is equal to 3. Okie dokie. So we know that this distance from here to here is 3. So we know for the denominator over here, it's 3. So our final answer is square root of 73 over 3. But, so we get this square root of 73 over 3. But then we have to ask ourselves, for secant, is it positive or negative? How do we know? So here, from yesterday, we learned that we know for, and please have this down in your notes, right? For yesterday's lesson, we know when sine is positive, sine is negative, cosine positive, cosine negative, tangent positive, tangent negative. Then the next question is, what about secant, cosecant, and cotangent? Okay, what was the idea? How did we know when was tangent positive and when was tangent negative? we proved that tangent of theta is equal to sine of theta over cosine theta. So then the next question we have is, okay, well, what about secant theta? What would that be? So let's take a look over here. Let's take a look at this one. So what I'm gonna say is that secant of theta is gonna be 1 over cosine theta. Okay, and let me show you a little proof for this. So we know, what do we know about secant theta? We know secant of theta is hypotenuse over adjacent. So the idea is, I'm going to say that this hypotenuse over adjacent is equal to 1 over cosine theta. Okay, but now, sorry, what do we know about cosine theta? This is 1 over adjacent over hypotenuse. Okay, because that's what cosine of theta is. So notice here we have 1 divided by adjacent over hypotenuse. But then what is this equal to? We have to do keep, change, flip. So keep, change, and then we flip it. 1 over hypotenuse over adjacent. And notice, what do we get at the end? We just get hypotenuse over adjacent. And that's what we wanted. We wanted to show that 1 over cosine theta would give us this, and notice that this matches. Okay, so now that we know secant theta is equal to 1 over cosine theta, so let's just take a look over here. So secant of theta is equal to 1 over cosine theta. So then what do we know about secant of theta? So let's see. When is secant positive? When is secant negative? So secant. Okay, so let me fix the camera angle a little bit. Okay, so we know secant of theta is 1 over cosine theta. So basically, what is 1 divided by a positive? Positive. What is 1 divided by a negative? Negative. What is 1 divided by a negative? Negative and positive. Basically, secant and cosine share the same attribute. So wherever cosine is positive, secant will be positive. Okay, so notice that cosine is positive in quadrants 1 and 4, right? So notice this cosine is positive here. So then secant has to be positive here. And the same idea that cosine is negative here, so secant is also negative here. All right, so notice that for here, there's a connection. You see how cosine and secant are connected. Also, sine and cosecant are connected. What do you think cosecant of theta is going to equal? Pause the video and take a guess, but it'll just be 1 over sine theta. Okay? And what will cotangent theta be? It'll be the reciprocal of tangent. So notice that tangent theta is sine over cosine. Cotangent is cosine over sine. Okay? So let's try and just figure out the rest. Here, if we have secant theta, let's look at cosecant theta. So cosecant, 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 cosecant. Okay? So notice how cosecant follows the sine. So wherever sine is positive, cosecant will also be positive. So notice that sine is negative, cosecant is negative. And then how do we do it for cotangent, the final one? This is cotangent, 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 cotangent. Okay? Here, cotangent is cosine over sine. So notice, what is positive divided by positive? Positive. What is negative divided by positive? Negative. Where is negative divided by negative is positive. Positive divided by negative is negative. Okay? And this is it. This is really, really, really muy importante to have. So please, if you don't have this, get like a sticky note, get an index card. Please have this, because this is really nice to have. It just shows within all the 6 trig functions where are they positive and where are they negative. Okay? And that will help us here. So notice that for our final answer over here, secant of A, this secant of A, secant is what? Secant is positive in quadrant 4, so this is our final answer. Right? Let's do one more together. This one won't be too bad. All right, what I want you to do is pause the video, copy this down, and try and do this question on your own. Okay? Here, it says given cosecant of A is square root of 65 over 7, and that angle A terminates in quadrant 2. So notice that we start over here. Okay, this is our start initial ray. Okay, and we're gonna rotate to the second quadrant, right? So we rotate somewhere here. Okay, and this is the angle. Right. Now what do? We create our triangle, and we know that this is angle A, right? So let's say if I made another triangle just so we could see the reference, right? This is angle A. So what do we know about cosecant of A? It's square root of 65 over 7. And what do we know about cosecant? Cosecant is hypotenuse over opposite. So notice that this is the hypotenuse and this is the opposite. So if I have this triangle here, what is the hypotenuse of A? This here to here is the hypotenuse of A. So we know that this is square root of 65. Okay. And what is the opposite to this angle A? This is opposite of the angle A, so this is 7 and this is 7. Okay? Now what is the question asking us to find? It's saying, hey, what's cosine of A? So notice that cosine of A, what do we know about cosine? Cosine is adjacent over hypotenuse. So notice, do we have the hypotenuse? Yes, it's square root of 65. Do we have the adjacent? No, we don't have the adjacent, so we need to find this missing side. So then what happens here? We have, if we have a triangle just like this, right? This is our C, this is our A, this is our B. So we have our A, so if we have A squared plus B squared equals C squared, right? Now, what happens from here? How do we actually figure this out? This will be 7 squared plus B squared equals square root of 65 squared. Okay? Right? Let me just make sure everything is okay. Yeah. All right, so this is 49 plus B squared equals square root of 65. I'm sorry, not square root of 65. What happens when you square the square root? This cancels. So let me just rewrite this again. So 49 plus B squared equals 65. Then how do you continue to the next step? We subtract 49 on both sides. So we have B squared equals 16, square root, so B is equal to 4. Okay, so we know that the adjacent side of this of angle A, we know that this measurement is 4. Okay, so this is 4 goes on top. All right, so now final question, what do we have to ask ourselves? This 4 over square root 65, is it positive or negative? So notice that we're in quadrant 2, cosine is negative in quadrant 2, so then we're left with this. Now, if you put this in, this is incorrect because we did everything except doing this part here that, remember, you cannot have a radical in the denominator. So don't forget, if you put this into delta math, you're wrong, because you have to rationalize the denominator. Okay, so if you have negative 4 over square root 65, what was the little trick we did to get rid of this radical in the denominator? We multiplied the top by square root 65 and the bottom by square root 65. So what happens on the bottom? This just becomes square root of 65, the whole thing squared, which cancels. So you're just left with 65 on the denominator. And what's left on top? Negative 4 radical 65. Okay? And this is your final answer for what cosine of A is in simplest radical form. Okay, happy face. I hope you enjoyed this lesson. Try and do some of the delta math questions, and you got this. I'll see you during the Google Hangouts or in class.